So, all right. So, these are some word problem situations that lend themselves to be solved by elimination a little bit better. Now, whenever we get next week, probably early next week, we will take our test on Chapter 7. And whenever we get to the test for Chapter 7, girls, quiet. Okay? When we get to our test for Chapter 7, we will, whenever we get to our test for Chapter 7, I won't necessarily tell you on the word problems which method you have to use to solve them. Okay? So, on the word problems, you can use substitution if it looks easier to you. You can use elimination if it looks easier to you. You don't have to specifically use a certain method for certain problems. There will be some where I may ask you to use elimination or substitution, but there'll probably be problems where you've got them like just the equations, not the word problems. So, but these, whenever you set these problems up, they're just a little bit easier to solve with elimination. So our first one is the sum of two numbers is 71. Their difference is 125. What is the product of the two numbers? So we could guess and check for a long time. Our numbers x and y. X plus y has to equal 71. Okay? And then, Gabe, what type of equation am I going to write for the second sentence? Their difference is 125. What? One with what? It's going to have variables. We're going to use that same x and y. What's that word difference mean? Subtract. So I'm going to say x minus y equals 125. Okay? So this works really nicely for this problem because you don't even have to multiply either equation. These just cancel. So 2x equals 196. You divide by 2. And x equals 98. Is that right? Okay. All right, questions there? X is 98. So, Evan, what do we do after that? We need to find y. How can we find it? Okay, Evan. We're going to plug in the x into either one of the first equations. I think I'll go with the first one. So 98 plus y equals 71. So I will subtract 98 from both sides. And when I do that, I'm going to get y equals negative 27. Okay? So, now, notice what they did here. What's the question asked for? Product of the two numbers. If they give you a question like this, multiple choice, they will almost always do that. Because if they give you a multiple choice question, and they just say what's one of the numbers or what are the two numbers, all you got to do is guess and check to get them right. Just check each answer, right? But if they give you the product, that becomes much more difficult to do. So a lot of times, if it's multiple choice, they'll ask something like this, what is the product of the two numbers? But I won't give this something like this to you unless it's calculator access. So you're going to do 98 times negative 27. Somebody do that for me. What do we get? Negative 2646. Oh, sorry. Better. 2646. Is that right? Okay. Questions? Write it down, Dylan. Okay. Let's see. Something's wrong with the sound. actually had this question a few years back for the senior play. They knew how much they charged for adults and for students. They knew how much money they made, but they didn't keep up with how many were student tickets and how many were adult tickets. So if you're wanting to know how many people attended the play, then you can set up a systems of equations and work backwards, and you can figure out how many students attended and how many adults attended. For the senior play, student tickets cost $4, adult tickets cost $7. The ticket takers know that they made $726 and that 126 people attended. But they forgot to count how many tickets were student tickets and how many were adult tickets. How many of each type of ticket did they sell? So, for this, you're going to write two equations. And that's pretty much the case for most of these. I mean, you're going to write two equations for all of these. But usually, there's a sentence for one equation and there's a sentence for another. So, the first thing we're going to use, oops, that is not what I wanted, right there. The first thing that we're going to do, well, I want that to go to the highlighter. This one's not working right. So the first sentence we're going to use is that we're going to talk about the cost of the tickets. So I'm going to let S be student tickets. The number of student tickets. And I'm going to let A be the number of adult tickets. We do not know how many they sold of each. Those are our variables. That's our unknown. So, if each student ticket costs $4, then I would say $4 times the number of student tickets. And then each adult ticket costs $7, so I'd have $7 times the number of adult tickets. That would equal how much money you made, which would be $726. Okay, so this is the first equation that we're going to write. It deals with the cost of the tickets. The second thing we know is that there were 126 people who attended. Now, that has nothing to do with how much they paid to get in. That's the number of people. So, that means that I'd take my number of student tickets and I'd add my number of adult tickets, and that would equal the number of people that were at the show. Okay, so here we've written one equation for our cost and another just for the number of people. Okay, so this gives us a problem that's pretty easy to solve using elimination. Riley, which one do you want to get rid of first, the S or the A? Okay, and so what would we need to multiply that bottom equation by so we could get rid of the S? -4. So we're going to multiply that bottom equation by -4. It's going to give us, let's see, top equation stays the same. I'm going to rewrite it. And so we'll have -4S minus 4A equals, let's see, 126 times 4. Where's my calculator at? It's going to give us -504. Okay, so I'm going to add those two together. These cancel. Here I get 3A equals, let's see, 222. And then I'm going to divide by 3 to solve for that A. And 222 divided by 3, 74. 74 adult tickets. Alright, we can plug back into either one of the equations to find the number of student tickets, or you know it's 126 total, so you could do 126 minus 74. But let's just use the equation. So we'd have S plus 74 equals 126 if we plugged into that bottom equation. And so you'd subtract 74. So S equals 52. Yes, thank you. I should have done that in my head. Okay, and so we've got 52 student tickets were sold. And 74 adult tickets. Make sure on these problems that you tell at the end what your 52 and your 74 are. The last problem didn't really matter because it was just two numbers. Actually, we had to give the products. But for this one, you've got to make sure you show what the student tickets and the adult tickets are. Okay, questions? All right, let's do another one. You have only 1s and 5s in your wallet. You have 17 bills in your wallet. Altogether, you have $49. How many 1s do you have? Okay, this is kind of similar to the last problem, but it's dealing with 1s and 5s, not necessarily tickets. So I tell students to think of this. You're counting. You can count two monies one way. You can count money two ways. You can count it the correct way, which is for each $1 you count $1, and for each $5 you count $5. That's how everybody counts money, right? If you have 17 bills in your wallet and you're counting out 5, 10, 15, 20, when you get to the 1, 12, 21, 22, 23, you'll count how much it's worth, right? Or you can count money like my 3-year-old counts money. And that is to count every bill exactly the same. My 8-year-old knows about this and often tries to take advantage of my 3-year-old because my 3-year-old would be happier with two $1 bills than he would be with one $100 bill because he has two pieces of money, which is more than one piece of money. Okay, so you can count money like a 3-year-old, or you can count money like you should hopefully count your money now. So that's kind of how you want to think of these whenever you set up these problems. So I'm going to use, I don't like using O as a variable, so I'm going to call this X for my 1s, and I'm going to do F for my 5s. Okay. I like to use the first letter of whatever I'm talking about, except for whenever, if O is a terrible variable because it looks like a 0 and then it gets you messed up. Also sometimes you might have two words that start with the same letter, so you don't want to do that in that case. So I'm going to have X is 1s, F is 5s. So if I'm counting money like my 3-year-old, then I would just take my number of 1s, which would be X, and I would add the number of 5s, which would be my F, and that would give me 17. So that would be like if you just pulled your money out of your wallet and you said 1, 2, 3, 4, 5, 6, counted every bill like it was $1, whether it was or was not. Okay? But you should not count money like that because you're going to be wrong more than likely unless you only have $1 bills. So what we should do when we count money is we should take all of our 1s. They are worth $1. So I'd have 1 times my number of 1s. Now, I could just write X for that. I don't have to write that 1. But for my 5s, they're all worth $5. So I would say 5 times F. And if I count this way, each 5 counts for 5, and each 1 counts for 1. And that's going to give me the amount of money I have, which is 49. Okay, questions on setting those up? Okay, so when we look at this one, Ian, what variable do you want to get rid of, the x or the f? Okay, x is easier, right? Because all you got to do is change the signs on one of those equations. Which equation do you want to change the signs for, the top one or the bottom one? All right, so top, negative, 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 just multiplying by -1 there. And so if I do that, the x's cancel like I wanted. What do I get when I add those together, Ian? So the x's will cancel. When I add the f's, what am I going to get? Good, 4f, because that's like a -1 right there. And then for the -17 plus 49, what do we get there? 32. And so I'm going to divide by 4. And f equals 8. So I have 8 $5 bills. Okay, that's worth $40, right? How many ones do I have? 9. I've got 9 $1 bills. Okay. Now, if you need to plug it back into the equation there, you can say 8 on x plus 8 equals 17. Subtract your 8. That's where you get your 9 from. So you have 9 ones, 8 fives. Okay, questions? All right, let's do one more. All right, so Josh buys 2 orders of fries and 2 burgers for $8.48. Jenny buys 3 orders of fries and 5 burgers for $18.02. How much does a burger cost? Okay, so we're going to write equations for both of these situations. I'm going to let f be fries, or actually it's the cost of the fries, because we know how many fries they buy. We don't know, so the cost of fries, and b is the cost of the burger. So if we're setting up an equation here, we're going to write an equation for Josh and an equation for Jenny. So Josh, he buys 2 orders of fries, so that's 2 times however much the fries cost, which is f. Plus he orders 2 burgers, and his total is $8.48. For Jenny, she orders 3 orders of fries and 5 burgers, and her total is $18.02. Okay, questions? Okay, now, do we want to get rid of the F or the B here? Okay, F's better. Why F? Okay, Julie's got the best answer right there. It's not really easier to get rid of the F, but we want to, the question doesn't ask us about the fries. It only asks us about the burgers, right? So we want burgers to be left whenever we're solving. Then we don't even have to plug back in. So if we get rid of fries here, that's better. Now, Julie, right now, they do not cancel. And there's nothing I can multiply 2 by that'll give me -3. So I'm going to have to multiply both of these equations. So what would we multiply? Okay, -3 on top, and then on the bottom, +2. Okay, and if you put the negative in the bottom instead of the top, doesn't matter there. but we'll go with what Julie told us to do here. So we get negative 6f minus 6b equals, we're going to need a calculator for that, 848 times 3. It's going to be negative 25.44. On the bottom, we're going to have 6f plus 10b equals, let's see, 36.04. Very good. Okay, so now those f's will cancel. We'll get 4b equals, we got to do 36.04 minus 25.44. We should get 10.6. 10.6. We're going to divide by 4. Whenever we do that, 2.65. So $2.65 for the burger. Now, that's our answer because it only asked us for the burger's cost. So we don't have to plug back in to find the cost of the fries. We could if they asked us for it, but we don't have to. Okay, questions? Okay. Your homework is going to come from for your homework, I want you guys to do, oops, pass that on back up here. Are we short one somewhere? Okay. See, pass that back to the corner there, Jesus. There we go. Okay. So I want you guys to do 1 through 6. Okay, for each one of these, you must write the equations and solve. Okay? So even if you could guess and check, that is not what I want you to do because what we're working on is setting up the equations and learning the algebra behind doing this. So 1 through 6, every one of them I need to see work where you have set up the equation so that you can solve. Okay?